you how to do this. Okay, cool. Cool. So let's do a few practice problems, feel everything out. Or actually, let's go over a few key concepts first. So this is kind of our equation right here. That's going to be our bread and butter for this, right? So we have three different parts of the equation. We have the percent of change, which is some percentage, right? We have the amount of change, and we have the original quantity. So the original quantity, for example, if this flower is 10 centimeters and it grows to 15 centimeters, what would be our original quantity in this case? And why is it 10 centimeters? So if something is increasing, the smaller number is going to be the original quantity, right? Because it starts smaller and it becomes bigger. This third number that we have is the amount of change. In this case, if our height was 10 and it grew to 15, what would be our amount of change? And how did you get 5? So to find our amount of change, this third number here, our strategy is going to be to subtract our bigger number minus our smaller number. So for an example, if let's say we were throwing a ball up in the air and it started at 15 feet and we threw it up to 30 feet. Our bigger number is 30 minus our smaller number 15, and our amount of change is equal to 15 feet. Does that make sense? Okay, cool. And so when we plug all of our numbers into our equation, we get our answer. So have you guys gone over both percent increase and percent decrease yet, or just percent increase? Okay, cool. So just to review, percent decrease, it's the same idea. Let's say, for example, an astronaut's weight decreased from 154 pounds to 25.5 pounds on the moon. Man lost a lot of weight. Or woman. We're doing the same idea, right? The amount of change is still equal to the bigger number minus our smaller number, and that gives us our amount of change, right? We're plugging into the same exact equation. Now, the difference with percent decrease is that our original quantity is going to be our larger number, right? So when we were doing percent increase in this problem, what was our original quantity? It was 10 centimeters, which was the smaller number. Whereas in this case, because the weight is decreasing, our bigger number is our original quantity. Does that make sense? Okay, so that's sort of the one little thing that we're going to have to remember as we work through these problems. So are you ready to do some practice? Perfect. Let us rock. Okay. So let's say 1 month, I can do 15 push-ups, and a month later, I can do 30 push-ups. What is my percent increase for the number of push-ups that I did? So what would be our first step in solving this problem? And do you remember how when we were doing the compound interest problems, we always wrote down our formula? I think that's a good idea. So at least when we're solving these problems for the first few times or the first few days, we should write out our formula every single time so that it sticks in our brain. Does that sound like a good plan? So we can say step 1 is write down equation. And what is our equation for these types of problems? And what is that equal to? So we have our amount of change, our original quantity. There's one more piece in here. It's the percent of change. So step number 1 is to write down our equation. I think a good step 2 is to decide whether it's a percent increase or percent decrease, right? So decide if it's increase or decrease. Well, in order to decide if it's an increase or decrease, we're going to have to decide which number is the original quantity and which number is the quantity that we're either increasing to or decreasing to, right? So in this problem right here, we went from 15 push-ups to 30 push-ups. What would be the original quantity? So let's write that down. Original quantity is equal to 15 push-ups. Okay. What is our amount of change? And how did you solve that? So when we're doing this, let's make sure we always write out our subtraction and our steps in between so that we can ask ourselves, hey, does this subtraction make sense? If it does, then good. If it doesn't, then we can sort of rework our problem. So in this case, our original quantity is smaller or bigger than our after quantity? So on month number 1, we did 15 push-ups, and month number 2, we did 30 push-ups. We've decided that 15 push-ups is our original quantity. So is this 30 greater than or less than 15? Right. So does that mean we have a percent increase or a percent decrease? Right. And why is it a percent increase and not a percent decrease? Exactly. That's 100% right. So if original quantity goes up, we have a percent increase. Which means if the original quantity goes down, we have what? Exactly. Okay, so we have our amount of change, right? We have our original quantity. And what are we trying to solve for in this equation right here? So let's write down here percent of change. And what I like to do to indicate that is just equals question mark. Okay, so we have our 3 numbers. We have our amount of change, we have our original quantity, and we know we're trying to decide for or solve for our percent change. So what would be our step number 3? Mm-hmm. Bang. And does that answer make sense? Exactly. Perfect. Okay, so this is going to be our cheat sheet for this type of problem for percent increase and percent decrease. I'll send this over to you after the session so that we can always look at it and look through these steps. And as we get better and better, using this cheat sheet will sort of allow us to memorize those steps. Alright, so let's try another practice problem. Let's try another percent increase problem. So let's say I work and I sell baseballs. I work at Gits Bros. And on month 3, so on the third month of the year, we have 66 baseballs. And the next month, on month 4, we have 88 baseballs. And what I want to know is what is the percent increase of baseballs? Okay, so step number 1, we're going to write down our equation. It's kind of annoying to do, but it's going to help us out in the long run. Trust me. So, what's our equation that we're working with here? Boom. Step number 1, done. Step number 2, we're going to decide if it's a percent increase or a percent decrease. And why is it a percent increase? And if the number of baseballs went from 66 to 65, would it still be a percent increase or would it be a percent decrease? If it went from 66 to 65. Because the number of balls decreased. Okay, perfect. Now we have to decide which number is our amount of change, what number is our original quantity, and what number is our percent of change. So, what would be our original quantity in this problem? I agree with you there. 66 baseballs. And what would be our amount of change? Okay, and how did you get 22? Our bigger number minus our smaller number. And what is our percent of change? Okay, so did you already plug into the equation? I agree. And just to make sure, we're going to write that percentage change down just so we know that that's what we're solving for. So what you did is you did the amount of change, our orange number here, plugged it in, so 22 divided by 66, and that equals 33%. Perfect, and that's the exact answer that I got. So do you have any questions about this process so far? Okay, cool. So just to review, we have this equation here. We need to write that equation down. We need to decide if it's an increase or decrease. We do that by looking at the original quantity. And if it's smaller than our second quantity, it's an increase. And if the original quantity is larger than the second quantity, then it's what? Then it's a decrease. Then we roll through, we decide which number is our original quantity, what's our amount of change, and then we plug into our equation. Okay, let's try another problem, because practice makes perfect. Okay, so let's say that I have a sunflower, and on day number 1, it's 20 centimeters tall. And on day number 2, it's 12 centimeters tall. So maybe it's dying a little bit, it's wilting down. I've already got my sunflower seeds, so it's shrinking down a little bit. And I want to find the percent decrease in the height of the sunflower. Alright, what's going to be my first step? Write down our equation. And what's our equation? And when I have, in this equation right here, what does this line between the amount of change and original quantity mean? Exactly. Okay, our step number 2, we're going to decide if it's an increase or decrease. And why is it a decrease? It went from 20 to 12. The original quantity is bigger than our second quantity, so we have a decrease. Okay, so in this case, what's our original quantity? And our amount of change? Right, we always do our bigger number minus our smaller number. Always, if it's increase or decrease, doesn't matter. Bigger number minus smaller number. And the percent of change is what we're trying to solve for. Alright, so we have our 3 variables. We have our percent of change, what we're trying to solve for. We have our original quantity equal to 20. And we have our amount of change. So let's go ahead and plug it into our equation. Yep, that looks good to me. And so if I had to say my answer in a sentence, what can I say? And what about the sunflower decreased? That sounds exactly right. The height of the sunflower decreased by 40%. Awesome, man. So this looks like it's coming naturally to you, which I love. So let's go ahead and do one more practice problem on our percent increase. Sound like a plan? Cool. So let's do this problem right here, the one that we looked at earlier. So the astronaut's weight decreased from 154 pounds to 25.5 pounds when he went from Earth to the moon. That's so cool. Did you actually know that that happens, that your weight decreases on the moon? Nice, yeah, and when you go to different planets, your weight changes. So, on Earth here, I'm in good shape, but on Jupiter, I am very, very large. But that's okay, because I've never gone to Jupiter. So, let's do our first step. And what's our equation? Boom. That's our moneymaker in this chapter. Percent of change. Perfect. Step number 2, we're going to decide if it's an increase or a decrease. And why is it a decrease, my friend? And so if it went from 154 to 25.5, what's our original quantity? And what's our amount of change? And how did you manage to figure that one out? And what's our little motto to remember how we subtract? Big number minus small number. You got that exactly right. 154 minus 25.5. That is equal to 4. Looks like 128.5. Do we know our percentage change? Alright, so let's go ahead and do that. That looks good to me. Bang, bang. That looks good to me. Did your teacher specify how many decimal places he wants? Like, does he want 83.44 or just 83? Did he mention anything specific? Okay, so that's what we're going to do, because if the teacher does it, that means that's what it's going to be like on the test. All right, do you have any final questions about this process before we go?